Okay, so we've got two source spheres. That's A, B. It's 2m the mass, and that's 3m. The opposite direction. This one's going at 4 meters per second, and then this one in the opposite direction at 2 meters per second. And we've got E is 0.4, separation of approach speed, and I need to find out where they're going to go. Well, this one's got the momentum mass times velocity of 8m, this one's got 6m, so eventually this one's got more momentum going to the right, so this one must go that way. I'm going to call that one y, and say that this one also goes at x. And I just need to apply a few things. Definitely going to apply conservation of momentum, and then I will have total initial momentum equals total final momentum. And this is very much worthwhile writing this down so you know exactly what you're talking about. So momentum, mass times velocity, so it's going to be 2m, or I'm going to take that way to be positive, and we've got 2m times by 4, and then that's going to be a minus because it goes the opposite way, minus 3m times by 2 must equal my final momentum, which will be 2m times by x plus 3m times by y, and cancel that by m, so 8 take away, that'll be 2 equals, and that'll be 2x plus 3y. So I've now got one equation, an x and y. I need to get another one, and I can use that using E, because I know that E is a separation speed over approach speed, and that equals 0.4. So a separation speed is going to be y take away x over the approach speed will obviously be 6. That's 0.4. And so y minus x will equal 2.4. And so y equals 2.4 plus x. And I can substitute that in up there to get 2 equals 2x plus 7.2 plus 3x, and that will give me that minus 5.2 equals 5x, so x equals minus 1.04, and then put it into there, and that will give me that y equals 2.4 minus 1.04, which will be 1.36. It wants a speed, and so I've got speed of A is 1.04 and speed of B is 1.36. The velocity is minus 1.04, but speed is 1.04. So that does the first bit, and then part 2, I'll do it up here. I've got to work out the loss of kinetic energy. So I want to work out what the total initial kinetic energy is, and kinetic energy is a half mv squared, and so that will be, the first one will be half times by the mass, which is times by 2m times by the velocity squared, that would be 4 squared, so that would be 16, and then plus a half times by 3m times by 4, and that will come to 22m, and the total final kinetic energy will equal the same sort of thing, a half 2m times by, I've just worked it out, 1.04 squared, and then plus a half times by 3m times by 1.36 squared, and that will give me 3.856 m, and therefore energy loss is 22 m minus 3.856 m, and that equals 18.144 m. That's excellent. And then finally, part 3. I've got given the magnitude of the impulse exerted on A by B. So I've got A and I've got B, and the magnitude of the force impulse on there, that's the impulse. And it says I know that impulse equals gain in momentum. I have to be careful about directions when I'm doing momentums. I don't have to be careful when I do energy because that's a scalar quantity, but impulse, and I'm going to go that way, so the impulse, that's positive, so it's going to give 2.52, is going to be gain, and so it's going to be the final momentum, which is the 2m times by 1.04, because I'm taking that to be positive, and x actually, I know it's x, it goes that way, but it's negative, so the velocity, the speed goes to the left, or velocity goes to the left, whatever. So it's the first thing, and I've got a minus 2m and times by, and the velocity is to the right initial velocity, so it's going to be times by negative 4. And that will give me 2.52 equals 10.08 m, and so m equals 0.25 kilograms. And that's work 6 out, and that's done.